Welcome back, and we're going to continue talking about sampling designs. And there are some better sampling designs. We talked about bias and kind of poor sampling designs in the previous video. So how do you remove that bias, or how do you make a better sampling design? And that's where we want to inject mathematics to some degree in our sampling strategies. Okay, and the element from mathematics that we're going to draw upon is the idea of probability. Okay, we haven't formally discussed it in the course, and that's fine, but it's this idea of chance. And we're going to inject it into our selection process, meaning that as we go through, there's going to be some way that we can um, associate a chance to selecting individuals uh, for our study. Okay, so and this idea is, even though it is a system, it does not favor one person over another. That's the whole idea. So it is not biased in that regard. While it is a system, it does not favor one group over another. Okay, so here are the sampling designs that we're going to talk about. Cluster is kind of a bonus. So in terms of the ones that you need to know, SRS, simple random samples, extremely important. Systematic, important. Stratified, meh, important-ish. And then cluster is just kind of another strategy. Okay, so simple random sample, we're going to abbreviate this SRS. This is kind of like if we had a holy grail of statistics, this would be it. This is kind of what we strive for at all times. Okay, and the idea is that you throw everybody into a pool and you randomly like pick out a number corresponding to a person and ask them to be a part of your study. Okay. Another way is you can have a computer do the assignment. So tell the computer to spit out a random number. Okay. And so the idea of everybody has the same chance to be drawn is kind of the idea behind a simple random sample. Okay, systematic sample is, kind of how I select the second person, and then every three people thereafter, so plus three, and so on and so forth. And so as long as you have a system, you maybe throw everybody in the pool, mix them up, or into a database, mix them up, and then select every third person to participate in your study. Okay, it is a system, but it is not favoring one person over another for any traits. It's just kind of going every, n units. The next one is a stratified sample. So what you do in a stratified sampling procedure is that you break the population into different groups. I don't want to use populations into different groups based on a certain factor. Okay, and those are called strata. So this is strata 1 and this is strata 2. Okay, for ease of thinking, think of it based on sex, so male and female. Okay, so you split the population, okay, based on some factor. And then within each strata, then you do an SRS. Okay, so this is a simple random sample in here. Okay, so in certain instances, you will need to do this because there might be some confounding factor or lurking variable that you're trying to control for. So so this accounts for that. Okay, and then in the next example, in the next sampling procedure, that's called a cluster sample. And what you do in a cluster sample is you break the population into different groups based on a different factor, okay? And then you randomly select those clusters, okay? So let's say, imagine the population is, so this is the entire population of a high school. Okay, and you're splitting it into different classes. So this is maybe, art class, this is bio class, this is math class, this is geography, and then this is, oh gosh, what's another one? English. Okay, and oh, that needs to be capitalized, isn't it? English or composition, whatever language you want to use. But anyway, so you have these different classes, and then you randomly select which classes you're going to ask to participate in your study. Okay, so whatever it is, whatever your different clusters are, a person can only be in one cluster at a given time. Okay, but you would take everybody from that given cluster and incorporate them into your sample. Okay, so each of these strategies, SRS, systematic, stratified, cluster, they have a certain system associated to them, but you're not privileging one group over another. You're using the mathematics via probability to kind of dissociate any sort of favoring that possibly could happen. Okay, and just know that these are kind of the tip of the iceberg, as it were, with the sampling methods, sampling designs. There's a lot more sampling designs, and in general, you different contexts are going to require different things too. So just be aware of them, and be sure that you can kind of justify why these are or aren't biased when you encounter a sampling design.